The direction of arrival of the start signal and the interference signals. The minimum value of distortion response, minimum multiple signal classification, the music, root music, slight advancement of music, the aspect technique, which is estimation of signal parameters by rotational invariance techniques. Most notably, the music, root music, and aspect levels are the most common. My research of this particular area typically involved applying those three levels in different circumstances and in different conditions and trying to figure out the best option as far as some scenario applications are concerned. A typical direction of the arrival estimation problem is something of that nature. In this particular case, we have some three signals emanating from some three different directions. The difference is the array axis down there. Down there we have some array axis composed of some four individual rotating elements arranged in a linear manner. A particular signal adding over there is some sort of planar, has some sort of a planar wavefront or something. Whichever arrives at the element to the right end will definitely be larger. Whichever is detected the element to this other end. That particular line is usually taken. One can work towards obtaining some expression corresponding to the detected signal as far as this particular element is concerned. And then we use that in reverse at the end of the day to try and somehow obtain something corresponding to those particular directions. Starting with brief explanation corresponding to the music estimation method. The very first equation of the equation n linear antenna array elements. That particular expression consists of the signals themselves, whereby the symbol alpha we are taking into considerations in case involving some m isomorphic signals, this means some n element in the antenna array. The S over here is indicative of the array response towards those particular incoming signals and some addition of noise over there. Equation 2 is basically equation 2. It has a slightly different format. Equation 3 is basically a matrix representative of the entire steering or array response vectors corresponding to the problem at hand. Some slight manipulations behind the music. The direction for the estimation method. At the end of the day, we turn out to be this particular expression. Somehow, this ends up being backward look at the behavior of a signal adding at some array structure. Basically, one ought to scroll through all possible directions of arrival by this particular expression. The points at which this particular expression is a maximum corresponds to signal direction of arrival. This particular expression is usually referred to as signal spectrum. The signal estimates that are required for proper estimation that we obtain from expression 12. The higher the number of signal points utilized, the better the combination will be. The root music estimation method is a slight improvement on the music estimation method. At the end of the day, if you learn the music estimation method, say flow approaches. And in this presentation, I want to cover introduction, overall presentation, the baseline, methodology, then overall research, and then the conclusion and information. And to start from the introduction, propeller open water can
characteristics. Usually when we are doing the shape design, there is a point where you need to know to decide the power from a ship and for a propeller when it's turning without a ship and when it's turning with a ship. So in this case, we are concentrated with the propeller. So we are not going to have the ship part, just the performance of a propeller. And the conventional way of finding these characteristics is usually through the turbine tank tests. Yeah? We're going to do an experiment using a model of the propeller which we have chosen in a turbine tank. And we realize that this turbine tank, usually it is the preliminary design and the concept. The idea is actually fake. So it will be very costly for you to produce the propellers at those steps. And then, if you want to make an adjustment, you will do all the dimensions. So it will be quite expensive. So to avoid that cost, we find that there is an application of computational fluid dynamics, whereby you can do simulations of a fluid. So you can compare different models and maybe come up with the best among those models. So far from those studies, it has been discovered that different models have different capabilities. For example, one model can be very good at predicting the torque. Yeah? But when it comes, we have steady flow and unsteady flow approaches, which can be used actually to study the propeller, the characteristic of a propeller. But we have not had a study comparing the two. When can you use a steady flow approach, or when can you use an unsteady? Take a time average. So the propeller goes one evolution. We take an average of the characteristics in that evolution. So that is the case of the state here. And because of that, we expect that from the developments we have, someone can simulate a whole ship. Instead of using a model whereby you scale down to, let's say, a ship of 5 meters, to using a software. So, and we have so many softwares which have been applied. We have the Wisdom, we have the Fluent, I can just mention a few. And then it has been realized that we have different turbulent models, as I've said, such as the 7 equation dynamics, the 2 equation, which is the K omega, the SST K omega. We also have the K epsilon, the one we have here, the risable and the normalized. And these turbulent models have shown different capabilities depending on giving different results, depending on the parameters you want to check. Then, in these studies, different bits have been used, ranging from the coarse, medium, and fine. Information comparing the two is limited. And that is what gave us a topic
of oil production to produce enough biodiesel that significantly replaces the current fossil fuel consumption. Now, microalgae as a feedstock for biodiesel production. Now, first of all, microalgae are a diverse group of aquatic photosynthetic microorganisms. They grow very fast and have the ability to yield large quantities of lipids adequate for biodiesel production. Now, the potential for microalgae to provide biomass for biodiesel, it has 30% oil in the biomass, it will give us 58,700 liters per hectare. Microalgae may be nutrients such as phosphorus and nitrogen and heavy metals from wastewater. Microalgae sequester or remove a large amount of carbon dioxide from the atmosphere via photosynthesis, e.g. the carbon dioxide fixation of chlorovulgaris was up to 260 milligrams per liter per hour in a membrane photobioreactor. Up to biomass resource for renewable energy production. Now, metabolic pathways. Microalgae may use one or more of the 3 main metabolic pathways, depending on carbon conditions and light. The first one, we call it photoautotrophic. This one uses CO2 as carbon source and light as energy source to make its own food. Then there's what we call heterotrophy. Heterotrophy, this one you have to provide a carbon source, for example glucose, so that it can carry out its function. Then there's mixotrophy, which comes under autotrophic or heterotrophic conditions at a temperature between 20 and 30 degrees Celsius. Now, raceway ponds are typically constructed using concrete shell lined with polyvinyl chloride. Dimensions for open ponds range from 10 to 200 meters in length and 1 to 10 meters in width, with a depth of microalgal growth of 10 to 50 centimeters. That's an example of what we call a flat plate airlift photobioreactor. Also, that's an example of what we call column photobioreactors. That's the ones up here. They represent tubular verticals photobioreactors. These ones are now tubular horizontal photobioreactors. Now that's a comparison of growing microalgae in open ponds and photobioreactors. Now you can see that when you are now challenges for commercialization, because already there's a lot of high concentration of oxygen to the plant. And then improvement of the competitiveness of oil-rich microalgae against water.
So the FDD, you have subcarriers. What happens is that in one FDD frame you have each being split into subcarriers, and these small sets of 15 Hz frequencies, one of them are combined to make what we call a resource block, which now are allocated to users dynamically. So then in the TDD frame, it becomes an orthogonal structure, where in the TDD now you have radio frames. These radio frames now are split in terms of slots. Here is whereby now you allocate users different slots, which can be split further into symbols. The symbols determine the bits transmitted, as I've explained. Here you have the radio frames now, which now could be slotted, could be further split into symbols. Now here the main schemes, we have got modulation schemes that are used in the LT. We have the QPSK or the 2 QAM, the 4 QAM. Then we have the 16 QAM, which uses 4 bits per symbols, and then we have 64 QAM, which uses 6 bits per symbols. So here the main scheme is adaptive modulation and coding technique that is used to determine the modulation scheme used in the OFDMA network. Situated in closed environments and office buildings. So they came up with small-sized base station or base networks, base stations which are called the home unit Bs, which are now referred to as the femtocells. So this becomes a major item of my research, whereby we say they are low power base stations that are just like Wi-Fi access points. Actually, they are called femtocell access points. They're just situated inside buildings. They are majorly just supposed to accommodate like 30, 32 users. And the further survey was done is that these users who are indoors, since the major base stations were outside there, the macro cells, they could not accommodate all these users, so they had to do some self-organizing network to be able to access, to create a femto cell within a building that does not have interferences with the outside network, and hence the self-organizing network technology was developed. You notice that 40% of users in buildings, even in developed countries, you have got these subway trains, they have problems with communication, accessing to communication. So that is whereby the femtocells came into play. Now, on to further development of LTE, we have these parameters that are normally used to check for the quality of service for LTE networks. We have got this quality channel indicator, which is a measure of the channel's worth in terms of transmitting information. Then we have the signal to noise ratio, which is just the ratio of the meaningful noise in meaningful information in a given signal. So you have the ratio of the noise signal, part of the signal to the entire signal. giving that ratio. It's called fairness algorithm. Here we have now narrowed down to femtocells, which is allocating resources. You'll notice that they took users who have got all types of signal interference ratios, plus miss ratios, and their power levels. So they are transferring the signal, the users, they are trying to optimize, just like they call fairness. They are trying to raise the power levels of the low SINR users in order for them to communicate their signal to noise ratios or signal to interference plus noise ratios are low. Switching data through a given medium, then they will introduce a predetermined parameter, which they are calling beta K. That is K is indicating the user serial. So they introduce this SINR users. So, but this one now it is just on the red side. It does not consider how much this user is requesting to how the user data is. Those calculations which are there. Then the mobility aware resource algorithm. This algorithm introduces the aspects of mobility of users. Now you will have users who are mobile within a given area, but now you are zeroing in on an indoor environment because you're dealing with a femtocell. So the approach here was to create clusters. Clusters were you cluster femtocells together, you group femtocells together. Then you have a cluster head with cluster members, which like we have got a macro and the micro ones being controlled by the major one. Then these micro ones are now the ones that are locating users. So it introduced the aspect of mobility in two aspects. One is the global prediction. Global prediction is whereby you will consider the movement, the historical path of the movement of the user in an array. Maybe it moved from room 1, 5, 7, 8. So that's a historical precedence that has been set. So using that, you can use to predict in that sequence in the future where this user will be at time X. Another one is local prediction, whereby you just assume this user is stationed at the station X, and any other adjacent, he can move to any other adjacent cell. And that way, you give an equal probability of moving to any, and hence you calculate the allocation using that technique. As I've stated, the prediction technique is not very accurate sometimes because users don't just follow historical paths. You can move to any room. So the prediction will not be very accurate, and sometimes also crisscrossing mobility. You know, I could just rush to this room and then come back for something small, rush to another room. So there's a crisscrossing paths by very many users, which becomes a problem with this technique. Be like altering the parent gene that was inherited, just a slight, or depending on the range of the what do you call it?
You can do this. Under the self-propulsion, you can see maybe it's not working. It is easier to adjust something in a software. Yeah? I can just adjust it and grab it up in the parameter. And if you think something is not working, you can just so if you change the profile of that propeller, or you change the angle of attack, you get different results. So this one is for this task application.
Alright, and the particular model you selected, K omega, well, I'm not very familiar with
Yes, from those studies, the K omega has the best results.
How deep you want to go into the model, because the finer it is, the more computationally expensive it is. Like now, the DNS is very expensive.
DNS is very expensive. But
then the LES, yes.
So
But the K epsilon is normally appropriate for most of.
Yeah, K epsilon is for industrial applications.
Whether now for this marine, whether you use physical models that you can be able to see the flow when you change the propeller is around here. Just tell us a little bit about maybe a mix about if there is, because what we need jkuat is a physical model. It's easier for us to imagine, just like you have for the military. Are they there?
Yeah, in jkuat you don't have a structure built across it, and on the ends it has rails. Yeah, just like a train, so it can it is powered by a motor. So using the motor, that the upper part and it itself move at different velocities. Now the part which is moving is usually attached to several tests can be done in a tiny tank. For example, you can test maybe the sea keeping, whereby it can be meant to move waves. There are artificial waves in a tiny tank, so it can be moving as you generate waves. Yeah? So that you can see how it reacts to the waves. Because ship resistance, it is usually in 3 parts. Yeah? There's the pressure, because there's a pressure difference in the water height. Yeah? And then there's the drag, because the water is sticking on the earth.
Last years, have you given a proposal? Because you can see the people in fluids and the thermal. I'm asking, how much money do you ask viewers now? Because that's now what the university understands. 40 million, 80 million, because you cannot have I'm saying, please, I'm just saying, I've got out of there, I'm just saying, it's a good thing because you can see at the end of it here. The propeller is actually the main thing for the ship. Just like that.
You're from Singapore or Marine. So I don't know how much Marine applied for, and it was in schools. So it was a school of mechanical and mechatronics and Marine. We also, in electrical, we also had a similar application.
Go through the market from the university. I'm just saying, I'm only saying he may not know. That's what idea. People not even invite me for when they were at that conference. But I'm saying I can see he was, and then our channel. This was a project identified by the government. So because I am one person was announcing this, once you finish your project proposal, then you look for reminder. Yes.
Maybe functions. As a highlight, we can talk about binomial, triangular, main, Blackman takes a triangular shape. This closely corresponds to a triangular window function, only that on a triangular window function, the starting point and the end point don't hit values of 0. But in this particular case, we have such a structure. These are the 2-point Bartlett window generated on the basis of expression 1. The Blackman window takes width as compared to the Blackman. The advantage that comes with that planar arrangement as opposed to maybe a linear antenna arrangement is the possibility of tracking sources or directing radiation or reception in a 3-dimension manner as opposed to a restriction that comes with a linear arrangement that maybe demands for direction of maximum radiation or reception in a 2-dimension view. The array, the rectangular antenna array radiation or reception pattern can be associated to this particular expression. This particular expression can be interpreted as the array factor corresponding to a rectangular array arrangement. Whereby, for instance, M, capital M, has to do with the number of elements in some X orientation, X direction, and Y direction. D is representative of element. So the selection of a windowing technique for any particular problem is dependent on, to a great extent, the location of directions of arrival associated with the interfering sources. I think that wave representation marks the end.
Now we have come to
that simplistic case.
One question? Yes. Which scenario? Just a signal, communication, is it a video? Is it some remote signal?
Okay. in the beamforming aspect, there are quite a number of layers that I ignored. A raw signal, loading an antenna array receiver, level, this one, level. All those aspects are missing from my presentation. I just talked about some blocks of the antenna array down to the beamforming aspect at this one, level. The signals featuring at this one, level with some simplistic scenario, especially only for interference, uniformly arranged around a single side.